Okay, this is lesson 6, nonlinear functions, exercise number 5. It was not in the video, so I'm going to do this one for you for the notes. The question is, why does the data in the table below indicate that the function could be linear? So if we're looking for linear, a linear function has to have a constant rate of change. So we have to look and see if the data has a constant rate of change. If it does, then it's linear. So let's look at the table. And if you look at the x values, we're going to look at how they change. So, excuse me, from 0 to 5 is plus 5, 5 to 10 plus 5, 10 to 15 plus 5. So what that means is our change in our x is 5. Okay? And then we'll look at the bottom at the y. From 11 to 8 is minus 3. 8 to 5 minus 3. 5 to 2 minus 3. So that means that our change in y is minus 3. So if we look at it, does it have a constant rate of change? It does. It changes the same throughout. So the question, why does the data in the table indicate that the function could be linear, is because it has a constant rate of change. So that's the reason for this. So the next part is we're going to write a linear function. And we're actually going to write the equation. So we need two things for that. We need the slope, which is the change in y over the change in x. And we actually already found that from our table. We don't have to do this again with 2 points because we have the numbers already. If I look up here, my change in y is negative 3. And my change in x is 5. So I already have m. I already have my slope. And then now I'm going to look for b, my y-intercept. So the y-intercept is always where x is equal to 0. So that's also already in the table. B is equal to 11. So now I can write a linear function, just like you've been doing, also using y equals mx plus b, and fill it in. Y equals negative 3 over 5x plus 11. And there's my linear function that models the data. Okay, so that's the last example on the notes. Hopefully you can do these and do the homework problems tomorrow. Let me know if you have any questions.